A block of silver of mass x kilogram hanging from a string is immersed in a liquid of relative density 0.72. If the relative density of silver is 10 and the tension in the string is 37.12 Newton, then compute the mass of the silver block. Here you have a beaker with the liquid of relative density 0.72. The ceiling, a mass of silver is being hanging from this ceiling. The weight of this silver block is in the downward direction and the liquid gives a upward buoyant force in the upward direction. The weight of the silver block is W, whereas the upward buoyant force is B. And in the string, there is a tension in the upward direction. We call it as T. Relation for equilibrium condition. Balancing these forces, we get W minus B equals T. W is the weight of the silver block, mass of the silver block multiply acceleration due to gravity, whereas the buoyant force is the weight of the liquid displaced. That's equals mass of the displaced liquid multiply the acceleration due to gravity. W is replaced by mass of silver multiply G. The buoyant force is replaced by mass of the displaced liquid multiply G. Now, we have to write the mass of the displaced liquid in terms of mass of silver. So, let us go for a simple derivation. Here, volume of the displaced liquid equals volume of the silver block. The volume equals mass per density. So, volume of the displaced liquid equals mass of the displaced liquid divided by density of the displaced liquid. Same way, volume of the silver block equals mass of the silver block divided by density of the silver block. What we need here is mass of the displaced liquid. So, mass of the displaced liquid equals density of the displaced liquid divided by density of silver block multiply mass of the silver. Let us write this formula here. So, we replace mass of the displaced liquid by density of the displaced liquid divided by density of silver multiply mass of the silver. Now, we have to write the ratio of density of displaced liquid to density of silver equals relative density of displaced liquid divided by relative density of the silver. Let us go for another derivation. Relative density of the substance equals density of the substance divided by density of water. We want density of the displaced liquid equals relative density of the displaced liquid multiply density of water. Same way, density of silver equals relative density of the silver multiply density of water. When we go for density of displaced liquid divided by density of silver, the density of water cancel, we get relative density of displaced liquid divided by relative density of silver. So, the density of displaced liquid divided by density of silver is replaced by relative density of the displaced liquid divided by relative density of the silver. Good. So here the common term is mass of the silver multiply G within bracket 1 minus relative density of the displaced liquid divided by relative density of the silver equals T. Mass of the silver we have to find, multiply 9.8, then relative density of the displaced liquid is 0.72 and relative density of silver is 10 and the tension in the string is 37.12 Newton. Substituting this, we get this equation. So, mass of the silver multiply 9.28 divided by 10 equals 37.12 divided by 9.8. When we simplify this equation, we get M mass of silver equals 4 kg. This 10 and 9.8 you simply cancel. 37.12 divided by 9.28 will give 4 kg.